Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting this morning will be the operation of my small cooler or small ref. Okay, that's a small ref. It is now plugged in. Okay, the green light. So meaning to say, this cooler now is operating, and we'll try to see if this mini cooler or mini ref is actually what you call this very very thrifty in the consumption of electricity. Anyway, this mini cooler is just a small one. The current consumption is not so much. So if I will try to monitor now the parameters that will be coming out if we try to operate this one. Okay, we'll try to go with the first one. The input voltage is 119.1. Okay, so this is AC operated. The current consumption is 0.52 ampere. The true watts, the true power consumption of this mini cooler or mini ref is 37 watts. Okay. And the total apparent power is 61.3. So we got a little bit of a difference from what you call this, from 37 to 61. That's the difference in value of the true power and apparent power. So supposed to be the power factor of this mini cooler is actually very low. Anyway, the current consumption is not so much. Okay, the frequency is 60 hertz. And as you can see it, PF meaning power factor is 0.59. So if this mini cooler could have been an industrial load and the power of that industrial load is 0.60, it's not a good power factor. But since this load here for the meantime is just a small load, okay, 0.60 is more than good enough already. But I am telling you that if this is an industrial load in which the power factor is 0.59 or 0.60, okay, the utility companies don't like this kind of power factor. It's very low. So the good thing about this one is actually you should have, or we should raise this 0.60 to something like 90 or 95. And if you could adjust it to operate at the so-called unity power factor, that's the best thing that we can do. Okay? So right now, this mini cooler is operating. Okay? Okay? This is a gift from Valview. Okay? And it just so happened that I am testing the so-called parameters if this mini cooler try to operate. Okay, I will repeat it one more time. The input voltage is 119.3 or almost 120 volts. The current consumption is 0.51 amperes. Okay. The true power is 36.9 or 37. The total apparent power is 61.2 volt ampere. This is the apparent power. It's not kVA, it's just only VA because this is just a small mini cooler. The frequency is 60 hertz. And last but not the least, the PF or power factor of this is 0.60. So maybe if you are operating an air conditioner in your house and the power factor is 0.60, okay, you will be paying so much utility bill. And just in case you're using an air conditioner which has a big capacity, you should try to install a power factor corrector or capacitor across your main line to increase the power factor from 0.60, and you could raise that one to 90 or 95%. And if you could do it 100%, that's the best one that you can do. Okay? So, this is Professor David J. De Los Reyes. What I presented is that I have shown you how to determine the power factor of a small cooler or mini ref using my meter. And this meter here comprises of a watt meter, ammeter, and a voltmeter, plus a frequency meter, because it measures voltage, it measures current, it measures true power, it measures apparent power, it measures frequency, and it measures power factor, the one we are dealing for the meantime. Good morning from Los Angeles. This is Professor David J. De Los Reyes.